Good morning. This is our video presentation for chromatography in food coloring of candy in food industry. This is the table of content. This is all of our group member, our name and also our metric number. The objective of our video presentation is to isolate and also recognize the various dyes found in different colored candy, which is in our cases we have choose M&M and also Skittles. So it's next is to analyze the dye formulations or similarly colored candies from various brands, which is again we are using the M&M and also Skittles. And third is to examine how solubility and molecular interaction influence the dye movement on chromatography paper. So for principles, this experiment it relies on concept of paper chromatography, which is a technique for separation that using the capillary action to transport the solvent across the stationary phase. The colorants in the sweet, which is M&M and also Skittles, will dissolve in the solution and also move at a different speed based on first is their solubility in the solvent, which is compound that is more soluble will move further, and also second is how they draw towards the paper fibers. Compound with less attraction will move further, their molecular dimension and polarity. And lastly is this leads to a visible separation of the dyes along the paper strip. Four phases. First is the preparation of samples. Candy dyes are obtained by dissolving them in purified water. Second is chromatography, arrangement, which is the strips are created. And then third is the growth stage. The chromatography strip is subsequently in the complete experiment positioned in beaker containing the solvent. And four is the division and supervision. As the solvent ascend, dye component divide according to the interaction with the paper and the solvent. Fifth is examination. The location and quantity of dye bands are examined to identify the makeup of dyes in each candy.
I'm going to talk about classification of chromatography. So, a classification of chromatography is a coloring chromatography of paper chromatography. It is a use for separating the sample mixture into its individual component. The paper is hung and bottom part of this paper is dipped on solvent. In this case, we have used solvent of M&M. Stationary phase, water molecule observed on the cellulose or a fiber paper. A mobile phase, which is the solvent, M&M solvent. So the concept of paper chromatography, when the sample mixture travels out to the paper, it will show that if non-polar compound weakly held and retained to a stationary phase and travel further with mobile phase. For polar compounds, strongly held and retained to a stationary phase and travel slower with mobile phase. And plus, non-polar compound it will eluted first, while the polar compound it will eluted later.
Next is methodology. The first part is preparing sample. Step 1. A dropper was used to place a drop of water on a plate. Step 2. A candy was set in a drop of water for 3 minutes. Step 3. The candy was removed and the color was extracted as sample. Step 4. Step 1 until 3 was repeated for different candy color. The second part is preparing paper strips. Step 1. Paper was cut into strips about 2.5 cm wide and 2 cm long. Step 2. The strip was cut long enough to touch the bottom of the beaker. Step 3. A line was drawn horizontally with a pencil from the bottom of each strip. Step 4. Each strip was labeled with candy color. Step 5. A dropper was used to mix part of the candy dye solution on the pencil line on the paper strip. Step 6. The paper was dry and reapplied for 3 times. Step 7. Step 1 until 6 were repeated for different candy color. The third part is chromatography separation. Step 1. 1 gram of salt was added into 1 liter of water. Step 2. The solution was stirred until the salt completely dissolved. Step 3. A binder clip was used to attach paper strip to a wooden skewer. Step 4. The wooden skewer was placed across the opening of the beaker. Step 5. The bottom of the strip was positioned about 2.5 cm above the bottom of the beaker. Step 6. The paper strip was removed, then a small amount of salt solution was poured into the beaker. Step 7. The wooden skewer with paper strip was placed again across the opening of the beaker. Step 8. The paper strip was positioned to touch the solution, but the pencil line was not submerged. Step 9. The solution was set to raise up the paper strip until it reached the top for 30 minutes. Step 10. The paper strip was removed from the beaker and a pencil mark was made to indicate how far the solution had risen.
Next, we will move to the calculating retention factors. For retention factor, this is the formula that we have used to calculate the RF, which is the distance traveled by the dyes will be divided with distance traveled by solvent front. This is the data for table 1, which is for NMN candy. This is the data for table 2, which is Skittles. This is the data analysis. So first is for the separation effectiveness. Both NMM and also Skittles, they show a different color separation, which indicate effective resolution of polar and also non-polar dyes. Skittle shows a greater RF values compared to NMN. This indicate the superior dye solubility or lesser interaction with pepper. And then next is the multi-dye detection. NMM green candy show two components, which is yellow-blue, rather than Skittles that only has one, which is yellow color. This highlight the difference of formulation. And then third is the solubility and also polarity trends, which is the lower RF, which the blue color 0.261 show a strong interaction with pepper, which it is more polar. And then the one with higher RF, which is Skittles green 0.449 show weak pepper interaction, which is less polar. And then the reproducibility, which is consistent solvent fronts, which is 4.6 to 4.9 cm across tests, ensure the standardized condition, which also will strengthen the analysis.
Next, we move to advantage, disadvantage, and use. Advantage. First, simple and inexpensive setup. The method uses common material, filter paper, water, beaker, making it low cost and ideal for educational or small-scale industrial testing. Second, effective separation of components. The paper chromatography technique allows dye from candy to be separated based on solubility and interaction with the paper, demonstrating its usefulness in analyzing complex dye mixture. Third, non-destructive method. The procedure does not chemically alter the dye. This allows for further testing if needed. Fourth, demonstrate solubility and polarity concept. The method helps assess solubility in water and movement in a polar medium, which is paper, as described in the principal section. Disadvantage. First, not quantitative. The method shows present or absent and migration distance of dye, but not their exact concentration or strength. Second, environmental sensitivity. Temperature, humidity, and even paper quality can affect dye movement and separation, potentially skewing the result. Third, time-consuming process. The candy must dissolve, dye must dry, and the strip must develop. Not practical for rapid testing in mass production setting. Fourth, limited resolution for similar dye. If two dyes have similar polarities or molecular weight, they might not separate well. Use in the food industry. First, identifying unauthorized colorant. It helps detect whether non-approved or excess dye are used in candies, supporting food safety. Second, educational tool for food chemists. Ideal for training and demonstration in food science lab, teaching concept of solubility, polarity, and analytical separation. Third, research and product development. Useful in R&D to test how dye behave in different solvent or interact with ingredient. Fourth, detecting batch variability. By comparing dye pattern across candy batch, quality control department can identify inconsistency in manufacturing.
So to conclude that the chromatography is one of the methods used by scientists to identify whether the solvent is polar or non-polar compound. Food coloring can be determined by using chromatography paper. It has been used for food industry for so many things such as comparing dye, position, or identifying unauthorized colorant and so much more. Classified as a planar chromatography or even clearer paper chromatography, which made of paper fiber.